today is look at i's and look at how we combine them like terms. So if you have an I plus an I, you treat it like an X plus an X. The powers have to be the same to combine them. So when we multiply, add, subtract, divide, you are looking for like terms. I to I is a like term. I squared to I squared, like term, so on and so forth. So in number 9 and 10, you're going to treat that exactly like you would as if those i's were x's. We're going to distribute the negative, combine the real and the imaginary. So distribute the negative to the 4 and the 8i. And then again, you want to keep it in a plus bi form. So you're going to put the reals at the beginning. So 3 minus 4 is negative 1. 6 plus 8 is 14i. Distribute, combine like terms. So you 6 minus I, because you have 3 and negative 4. In 11, we're going to distribute. There's only one I term, so we're going to combine the reals and leave the imaginary. And then in 12, the real stays, and we're going to combine the i's. So negative 6i plus 3i is negative 3i. So the combining like terms part is pretty easy. It's very straightforward. You're just adding and subtracting. Then we look at multiplying. And with multiplying, it's really important that you know your powers of I from yesterday. So in that first example, we just have 3i times 8i. And again, if you think of I like a variable x, that means you multiply your numbers. So 3 times 8 is 24. X times x would give you x squared. So I times I will give you I squared. But we don't want to leave any powers on our i's. So final answers must always have I to the power of 1. So you're going to go back to yesterday and say, okay, well, I squared is negative 1. So instead of being 24i squared, it becomes negative 24. And we see that 2 imaginary numbers multiplied together become a real number. 2 imaginaries multiplied together become a real number. So 12i times 7i. So again, 12 times 7. So you have 84 I squared. We want to change the I squared to negative 1. So you have negative 84. Order of operations say exponents before multiplying. So in this example here, it's 2i, and that's really the same as times 3i times 3i. People have a tendency to want to multiply the 2 and the 3 is 6, and then square 6. But order of operations would tell us that I have to square the 3i first, then multiply. So you get 2i times 9i squared. So I don't end up with 6 squared or 36, I end up with 18 I cubed. Because I times I squared becomes I cubed, but I cubed is negative I. So then I have 18 times negative I, which is really negative 18i. Or again, right here, I could have changed 9i squared to be 2i times negative 9. Like I could have changed my I squared sooner and not gotten I cubed. Either way, I would have led myself to negative 18i. So again, it's just the way you think and the way I think may not always align, but our final answer should. A negative 2i squared, well, that negative is going to go to the 2. But when you square anything that's negative, it becomes positive. So you got to be really careful to make sure that negative 2i becomes a positive 4i squared. So then you get 20i cubed or negative 20i. Okay, 11. So what we're going to do is FOIL. So again, a binomial times a binomial says to FOIL. So you're going to do first, outer, inner, last. So you get 6, negative 12i, negative 14i, positive 28i squared, change I squared and combine like terms. So you have 6 minus 26i minus 28. Once again, I have like terms between the 6 and the 28. So I get negative 22 minus 26i. Real plus imaginary. Minus 18i minus 20i plus 15i squared. 24 minus 38i minus 15. 24 minus 15 is 9 minus 38i. All of our answers should either be a real number, an imaginary number, or a sum of a real and imaginary, but you should never have more than 2 terms because everything should combine together. The last thing is introducing a complex conjugate. A complex conjugate is the number or operation that you can multiply by to rationalize the denominator. So a rationalized denominator will contain no i's or no square roots. So a rationalized denominator can only contain a whole number. So our goal is to rationalize our denominator, which means the denominator can only have a whole number. The complex conjugate is A minus BI. In the sense that it is always going to be the additive inverse of the denominator. The goal of a complex conjugate is to create a difference of squares in a sense such that the insides of FOIL will cancel. So it's just like our square roots, that when we had to rationalize that denominator, you multiplied by your complex conjugate. So in example 15, that complex conjugate is 3 minus 6i. Because the first term stays the same, the second term becomes its opposite. So it's the additive inverses of the imaginary parts. If I multiply the bottom by 3 minus 6i, algebraically I have to also multiply the top, because that's like multiplying by 1. So if I multiply the bottom, I must also multiply the top. Then I'm going to distribute and FOIL. So 2i times 3 is 6i. 2i times 6i is negative 12i squared over 3 times 3, which is 9, negative 18i, positive 18i, minus 36i squared. So again, you can see that once I combine like terms, the two middle terms in the bottom should cancel. That will leave me with 6i minus 12i squared over 9 minus 36 I squared. And then we want to do what we've been doing, take all of the I squareds, turn them to negative ones, convert the negative 1 times that number. So in this case, you get 6i plus 12 over 9 plus 36. Rewrite your top so that it is an A plus BI order. So you have 12 plus 6i, and then 9 plus 36 is 45. Now, 45, 12, and 6 all have a GCF of 3. So technically you could reduce all of these by taking out a factor of 3. So the simplest form would be 12 divided by 3, which is 4, 6 divided by 3, which is 2, and 45 divided by 3, which is 15. You cannot simply divide 1. You also can't cancel the 12s and the 36 here to be 1/3. You can only take away from every term, not in individual terms. Now, the bottom is a slight variation. So remember, it's the additive inverse of the imaginary part. So in this case, this is kind of like 0 plus 5i, which means the complex conjugate would be 0 minus 5i. But we know in math we don't need to write that 0 out. So in number 16, we're going to multiply the top and bottom by negative 5i. That will give negative 20i minus 5i squared over negative 25i squared. Changing all of my I squareds to negative 1 and flipping my top to be an a plus bi 4, I get 5 minus 20i all over a positive 25. You can, once again, reduce by dividing by 5. So you would have 1 minus 4i over 5. Okay, homework's the front and back of that next page.